A reciprocal trig identity to prove here. Nice. So I'm going to start from the left-hand side because that one's involving a fraction and I can combine that fraction and I'm going to try and get to the right-hand side. The left-hand side is identical to, let's put this over a common denominator. So I'm going to get cosec theta plus 1 over cosec theta minus 1 times cosec theta plus 1 plus cosec theta minus 1 over the same thing. I can bring this together, add them together, I'm going to get 2 cosec theta plus 1 minus 1, that's going to cancel all over that bracket, which I'm now going to expand. This will give me cosec squared theta minus 1. Right, so that's step 1 done. There's still quite a lot to do because we've got a tan and a sec in the answer, and at the moment it's just cosec. So let's think about any identities. You might know them off by heart. I don't. I just always derive them. So sine squared plus cos squared is 1. All right, I know that one. And then if I want cosec squared, I'm going to divide through by sine squared. So I'd get 1 plus cos squared over sine squared. That's actually cot squared. And that's going to equal, or be identical to cosec squared, which means cosec squared minus 1 is going to be cot squared. All right, brilliant. That is our next line then. So we can replace the denominator by cot squared theta. Yeah, and let's keep going. So now I'm going to write it as 2 over sine theta, because that is my 2 cosec theta, over cot squared theta, which is actually going to be cos squared theta over sine squared theta. Now in the final answer, yeah, we do have a reciprocal trig, but we also got tan. So I think let's just get everything in terms of normal trig now, and then sort it out after. So we'll get 2 over sine theta, then we'll keep change flip. I'm going to times by sine squared theta over cos squared theta. These are actually going to cancel partially, leaving me 2 sine theta over cos theta multiplied by 1 over cos theta. I've just separated it into these different fractions because, remember, I'm trying to get to tan theta sec theta, which I now have. This is the right-hand side. Proof complete. So just looking back, I'd say that this is definitely the route to go. Now, when you get to here, I used reciprocal trig identities. There is another way we could have done it. We could at this point have times through by sine squared. You might be just a little bit happier to deal with normal trig than reciprocal trig. If you times through by sine squared, you would have got 2 sine theta at the top, because when you times by sine squared, one of the signs cancel, we're just left with that sign. And on the bottom, we'd get 1 minus sine squared theta. And that is pretty nice, actually. And then you can just use the fact that 1 minus sine squared is cos squared to give 2 sine theta over cos squared theta. So we do get to this stage without having to deal with like the fractions and everything. Sometimes it's definitely good to leave it in terms of reciprocal trig. Here, I'd say actually that way is slightly nicer, but just make sure you understand both and can use both reciprocal trig and your normal trig. Hence solve for x between 0 and 90 this equation here. And the hence is basically telling us, like, use that identity that you just found in the first part. So the first thing I'm going to do is write down 2 tan 2x sec 2x. That's all I've done. I've just replaced this, but now I've got a 2x here. I need to just slightly modify the identity, and that is going to equal cot 2x sec 2x. Now, sec can never equal 0. It's 1 over cos. It ranges from 1 to infinity or -1 to minus infinity, which means we can actually just divide through by it, and it's gone. Normally, when you divide through by a function like this, you have to consider if it's equal to 0. Well, actually, that's what I did do. I just said it can never equal 0. A bit like with an exponential, you can just cancel it out. You might be a bit happier minusing it, minusing these two, and then factorizing the sec 2x out, and then thinking, right, this is either equals 0 or this is equal to 0, but you'll quickly see that there's no solution to that one, and we get to the same place. So 2 tan 2x is cot 2x. Right, where to go from here? Don't forget we're solving between 0 and 90. Actually, I'm going to now change the range then. So it's going to, 2x is actually going to be between 0 and 180. So I'm going to get all my solutions for 2x between 0 and 180 and then divide through by 2. Now, cot 2x is actually 1 over tan 2x. So that's my next line. And then I'm going to times through by tan 2x. So I'll get tan squared 2x equals 2 tan squared 2x equals 1. And then I'm going to divide through by 2 to get a half here. And then tan 2x is going to be plus or minus root a half or 1 over root 2. Okay, just got to solve each of these separately. So tan 2x equals 1 over root 2 first of all. Let me sketch out the tan graph in this interval. So I'm going to have it looking like that. And then we've got 90 and here. Right, so I'm going to first of all be getting this solution here. 2x is going to be inverse tan of 1 over root 2. Make sure your calculator is in degrees. And we get 35.264. That is the only solution I'm going to have in the range. If I add on 180, I'm going to be outside of the range, so we're sorted. Right, I will divide through by 2 at this point and round to 1 decimal place. I'm going to get 17.6. Or I'm going to get tan 2x equal to minus 1 over root 2. And now I'm looking along here. So then just do the same thing, but with the minus there. This gives minus 35.264. That's outside the range. I'm not even going to write it down, but my next solution is going to come from adding 180. That's the periodicity of tan. So we're going to get 144.73. So just to say, we have just found this one here. Technically, we're actually plotting y equals tan 2x with 2x here. That's why you can always draw, you don't have to worry that this is a tan 2x graph. We're solving for tan 2x. It's like we've done a substitution, so you can still use a normal tan graph. Just want to highlight that. Divide through by 2 gives us x equals 72.4. Good job.